In this video, let us visualize the layout of the fourth extended file system. This image was introduced in the video on Introduction to File Systems. Our focus will be on File System 1. Let us assume the partition has been formatted as fourth extended file system. It has been reiterated that a file system organizes data in a precise, methodical way. To do this, EXT4 first divides the file system space into blocks of equal size. The block size may be 1024 bytes or 2048 bytes or 4096 bytes. When a partition is being formatted as fourth extended file system, EXT4 will judiciously pick a block size based on the size of the partition. To make it easier to refer to each block, consecutive blocks are grouped together. It is imperative that each group has the same number of blocks. This rule is relaxed for the last group as it has only the remaining blocks that have not already been grouped. Here you can see that the first group has 3 blocks, 1, 2, 3. The second and third groups also have 3 blocks each. The last group has only 2 blocks which are remaining in the file system. So the last group always has the same number or less number of blocks than the preceding groups. The fourth extended file system has baptized these groups as block groups. Each block group is identified by a number. This numbering begins from 0. So for n block groups, the numbering would be from 0 to n-1. Here we have 4 block groups numbered from 0 to 3. Let us pick one block group and appreciate its internal layout. If you can recall, I had mentioned earlier that any file system uses special data structures to organize its data. The data structures unique to EXT4 can be found within one block group. As you can see here, the data structures are as follows: superblock, group descriptor table, block bitmap, inode bitmap, inode table, and the data area. The data structures are laid out in this exact order, and the same ordering is repeated in the other block groups too. Let me summarize what we have discussed in this video. The EXT4 file system is stored as blocks of fixed size. Consecutive blocks are grouped together in block groups, with each group having the same number of blocks except the last group. Within each block group, a unique layout of data structures is found. The data structures include superblock, group descriptor table, block bitmap, inode bitmap, inode table, and data area.